Good morning, students. Welcome to video lecturing class on dynamics of machines. So we will continue with the problems on balancing of rotating mass. Here is the statement of the next problem. A 3.6 meter long shaft carries 3 pulleys, 2 at its 2 ends and the third pulley at the midpoint. The 2 end pulleys have masses 79 and 40 kg respectively, and their CG, that is center of gravity, are 3 mm and 5 mm from the axis of the shaft respectively. The middle pulley has a mass of 50 kg and the CG is 8 mm. The pulleys are so keyed to the shaft that the assembly is in static balance. The shaft rotates at 300 rpm in 2 bearings 2.4 meter apart with equal overhangs on either side. Determine the first one, relative angular position of pulleys. Second one, dynamic reaction on the 2 pulleys. Before starting with the solution, first you need to draw this line diagram and this space diagram. So in the given data, he has given that shaft is carrying 3 pulleys. Let us name those pulleys as A, B, C, and he has given their masses and their CG, that is radius of rotation. So here I have taken 2 reference planes L and M, which are at a distance of 0.6 meter from A and 0.6 meter from C. And this B is at the midpoint of the shaft. This is the space diagram. Then you need to construct the tabular column. In the first column, write the planes namings A, L, B, M, C, and second column masses, for which he has given. For the A, B, C he has given. Then a radius of rotation. Force is you need to calculate, that is M into R. So it is 0.237 for mass A, MLRL 0.4, MMRM and 0.2. Then the distance from the reference plane. So here I have taken reference plane as the L plane. Okay. So whichever the masses are towards the left side and their distances you have to take with a negative sign, and right side you have to take with positive sign. So for A it is minus 0.6 and for L it is 0 and for B it is 1.2 and for M it is 2.4 and for C it is 3, and a couple you need to calculate by multiplying this force to this distance. We get these values. So that need to check which polygon you have to draw first. So in this case, he has not given the angular position for any of the masses. So for that, first we'll assume that the system is in static balance. So we'll ignore the planes L and M. We'll consider only A, B, C. From those given values, we can calculate the force terms for the A, B, C. With help of those forces, we can construct the force polygon for the static balance. So that is in this column, that is in the force column. We ignore this MLRL and MMRM. Let us assume that the plane mass MA is along the horizontal plane. So start from here, it is with positive sign. O to A, length of the line should be 0.237 and it should be horizontal. Then to get the complete polygon, for mass B it is 0.4 and for mass C it is 0.2. So after A you have to consider B value. So take this A as center point and 0.4 as radius, draw an arc. Then take 0.2 as radius, O as center point, draw an arc to cut that previously drawn arc. So that you will get the point B. Then you join that intersection point to O and to A to get the complete force polygon. So from this you can get the angle for mass B and angle for mass C with respect to mass A. That is, for mass B it is 154 degree and for mass C it is 306 degree. Once you get the angular position, here in this, in couple column only one unknown is there. So first we'll construct the couple polygon with the help of those angles. We'll try to get the value of this mass in the plane M. So for that, first term it is with a negative sign. So O to A, length of the line should be 0.41422. Here I have taken the scale as 20:1. Then draw a line of length 0.48 and you should make an angle theta B, that is 154 degree till B. Then from a B, draw a line of length 0.6 in magnitude and angle should be 306. So these 154 and 306 got it from this static force polygon. Then join this C to O to complete the couple polygon and measure this distance C to O should be equal to 2.4 times of mm into rm. So from couple polygon, OC into scale equal to 2.4 into mm into rm. From that you will get mm into rm as 0.146. Okay. Then now we'll consider the force column. First, start from O to A, length of the line should be 0.237. So here I am drawing in this direction because it is with positive sign. While constructing the couple polygon, we started in this direction because the first term is in with the negative sign. So O to A, then A to B should be 0.4 and angle is 154, and B to C, length should be mm into rm, which you have got it from the couple polygon, and angle is 51 degree. Again this angle also I got it from couple polygon. Then from C, draw a line of length 0.2 in magnitude and angle should be 306 degree. Then join this point to the starting point to complete the polygon, and here I have taken scale as 20:1 and the length of this line should be equal to ml into rm. Now from this couple polygon got the value of mm into rm. For the dynamic force on the bearings M, can write the equation as mm into omega square into rm. So we have got the value of mm into rm as 0.146, and he has given the speed n as 300 rpm. Substituting, we'll get it as 144.1 Newton, and theta m, we have got it from couple polygon as 51 degree with respect to mass A, which is measured in counterclockwise direction. Now from force polygon, OD into scale equal to ml into RL. From that we will get the value of ml into RL as 0.155. So dynamic force on the bearing L you can calculate by using this formula, that is ml into omega square into RL. Substituting the values, we will get the dynamic force on bearing L as 152.98 Newton, and the angular position for that one is 235 degree with respect to mass A, which is measured in counterclockwise direction. Now moving further, next problem statement. Four masses A, B, C and D revolve at equal radii and are equally spaced along the shaft. The mass B is 6 kg and the radii of C and D make 90 degree and 240 degree with respect to B. Find the magnitude of masses A, C, D and the angular position of A so that the system may be completely balanced. So here he has given that they are having the equal radius of rotation. So let us assume that it is 1 meter, that is RA equal to RB equal to RC equal to RD, which is equal to R. That is the assumption which we made from the given statement. Then tabular column, before that they are equally spaced 1 meter apart, and he has given the angles. This is the space diagram. In the first you construct the tabular column A, B, C, D, M, A. Here we know only mass B, and the radius of rotation is same for all the masses. Force, that is the reason why I written it as omega square by R. Directly we can take this column here only for the simplification. Otherwise we can keep it as MA into R. We can substitute R as 1 meter. Similarly, distance from the reference plane. So here I have taken reference plane as A. For A it is 0, for B it is 1, C 2 and D 3. Couple, multiplication of these two will get the couple column. Then first we will try to construct the couple polygon, because in couple column 2 unknowns, in the force column 3 unknowns. So we will start with the least unknown column. So couple polygon, first the length is 6 in magnitude. Here I have taken scale as 1:1. O to A length should be 6 in magnitude. Then for B and C he has given, for C and D he has given the angle as 90 degree and 240 degree. We will make use of that angle to complete the couple, because both the values are unknown here. So from A, draw a perpendicular line. Then we don't know where exactly this point lies for that reason, but we know the angle should be 240 degree. So this inside angle will be 30 degree, because from here to here it will be 270 degree. So from O, draw a line of random length, and this angle should be 30, so that automatically it will become 240 here. So draw a line till it intersect with this perpendicular line. Wherever those two lines intersect, that point is going to be your B. And the length of this line should be equal to 2mc, and length of this line should be equal to 3mb. So from couple polygon, you can get the value of md and mc. Once you get those two values, then go for the force polygon. So start from O to A, length should be 6. So here I have taken scale as 1:1. Then from A, draw perpendicular line of length 5.075. So this value I got it from this couple polygon. Then from B, draw a line of length 3.93 and angle should be 240. Again this MD value you got it from this couple polygon. Then join this C to O to get the value of ME. That is, the calculation part is couple polygon 3MD should be equal to OB into scale. From that you got it the MD as 3.93 kg and MC as 5.075 kg. And from the force polygon, theta A is 204 degree with respect to counterclockwise direction, and MA is 4.3 kg. Then next problem is 4 masses of magnitude 5, 6, 7 and m kg revolve in planes A, B, C and D respectively. The planes are spaced A to B 0.8 meter, A to C 1.2 meter and A to D 2 meter. The masses are all at the same radius of rotation. Find the magnitude of m and relative angular position for complete balance. So first we will try to construct the line diagram and space diagram. So here he has given the magnitude of 3 masses and 1 mass is unknown. He has given spacing between A to B and A to C. A to B he has given it as 0.8 and A to C he has given it as 1.2 meter. Then after construction of this line diagram, and he has given C to D as also 0.8 meter. Now we will try to construct the force and couple polygon depending upon the number of unknowns. Then tabular column A, B, C, D, and here masses. He has given 3 masses, only 1 mass is unknown, that is which is acting on plane D. He has given all the radius of rotation are same. Force, calculate. Distance from reference plane. So here I have taken reference plane as a D because this is the unknown mass. So I will take this D as unknown. And whatever the planes are acting towards left side and their respective distance you have to take with a negative sign. So it is minus 2 meter for A, for B it is minus 1.2, for C it is minus 0.8. Likewise you calculate the couple. Then first we'll try to construct the couple polygon because there are no unknowns. Okay. But here all the values are with a negative sign. So we'll start from O. O to A should be in magnitude as 10 and the direction should be opposite because it is minus 10. Then we don't know the angular position for the remaining two masses, but we know the magnitude as 7.2 and 5.6. So now take this A as 7.2 as center point and 7.2 as radius. Draw an arc towards downside because that value is also with a negative sign, so we need to go in opposite direction. So draw an arc here. Don't draw arc above this horizontal line. Okay. Then take my 5.6 as radius, this O as center point, draw an arc to get this point B. Then join these points to get the complete polygon. And while measuring the angles here, don't measure this angle because only because of that negative sign we have changed its direction. So you have to measure angle in counterclockwise only. For that reason theta B will be here, this much, not this whole angle. Now once you construct this couple polygon, you will get the values for these angles theta C and theta B. Now theta B is 147 degree and theta C is 224 degree. After that you construct the force polygon. Start from O to A in magnitude should be 5. Then A to B in magnitude should be 6 and angle should be 147 degree. Then B to C in magnitude it should be 7 and angle is 224. These two angles you got it from this couple polygon. Then join this C to O to complete the polygon. Thus length of this CO should be equal to M. So from force polygon got the angle for D, that is theta D is 17.5 degree, that is this angle, and OC into scale should be equal to M. From that we get the mass in plane D as 5.4 kg. Then moving further, the four masses of magnitude 5, 6, M and 8 kg revolve in planes A, B, C and D respectively. The planes B, C, D are placed at a distance of 0.3 meter, 1.2 meter and 2 meter respectively from A. The masses are at the same radius of rotation, that is the value is 0.3 meter. Find the magnitude of M and relative angular position of all the masses for complete balance. It is similar to the previous, only difference is there the fourth mass was unknown, here third mass is unknown. So first you construct this line diagram with the help of given data and this space diagram. Then you construct the tabular column. So in tabular column, third mass, that is mass which is acting in plane C is unknown. Radius of rotation here it has given it as 0.3. For simplification purpose, I have taken it as omega, the force divided by omega square by r. Otherwise, you can keep it as force by omega square. That time this is going to change. But final answer you are going to get the correct answer on that. Then distance from reference plane. So here I have taken C as the reference plane. So these two distances I have to take with negative sign. Once you complete this tabular column, first we'll construct the couple polygon. It is minus 6. So O to A should be minus 6 and it should be in opposite direction because it is because of this negative sign. Then we don't know the remaining angles, so we'll take 5.4 as radius, this A as center point, draw an arc below this horizontal line, not above, because again that is also with minus sign. Then 6.4 as radius, this point as center point, draw an arc to cut that previously drawn arc. So that you will get the angle for B and angle for D. Once you get those two angles, then go for construction of force polygon. First 5, 6, M8 is there. First magnitude should be 5. I have taken scale as 1:2. Then for second, the angle should be 112. Should start from A, and magnitude should be 6. Then from B to C, length is 8. So here you skip this because this is unknown. You have to jump to the next one. So 8 and angle is 52 degrees. So here these two angles you got it from the couple polygon. Then join this C to O to complete the force polygon, and the length of this C to O should be equal to M. So from force polygon, OC into scale equal to M. From that you get the M as 14 kg and theta C as 237 degree with respect to MA, which is measured in counterclockwise direction. Then moving further, a shaft carries 3 masses in planes A, B and C. Planes B and C are 600 mm and 1200 mm from plane A. Masses in planes A, B and C are 50, 40, 60 kg respectively at a radius of rotation 25 mm. The angular position of mass B and C with respect to A are 90 degree and 210 degree. Find the unbalanced force and couple if the shaft revolves at 300 rpm. Also find the position and magnitude of balancing mass required at 100 mm radius in planes L and M midway between A and B and between B and C. So first, with the above given data, we try to construct the line diagram. So here is given that 3 masses A, B, C, and he has given their distance between for B and C are 600 and 1200 mm apart. From A, B is 600 mm and from A, C is 1200 mm. Then along with that, he has given the distance for this L and M. L and M are exactly at the mid of AB and BC. Okay. Then this is the space diagram you need to construct with help of given mass and angle. Then construct the tabular column. So here in the first column it is plane A, L, B, M, C, 50, BL, 40, BM and 60. Radius of rotation for the ABC he has given it as 0.025, and for the balancing masses he has given it as 0.1. So here you cannot write force divided by omega square into R. Okay, so you have to write only force divided by omega square, then force will be M into R. Multiply these two, write the terms for here. Then distance from reference plane. So here I have taken reference plane as L as the reference plane. Then couple, that is force into distance from reference plane. So now he asked us to calculate the unbalanced force and unbalanced couple. For that, first we will ignore the balancing planes. So we will consider only A, B, C. With the help of those masses, we will try to construct the force polygon first. So here for the force polygon, first is 0.25 should be the magnitude. Sorry, 1.25 should be the magnitude, and angle is 0. So 0 O to A magnitude, in magnitude it is 1.25. Then A to B should be 1 in magnitude and angle should be 90 degree. Then from B to C the magnitude is 1.5 and angle is 210 degree. And then join this C to O to get the unbalanced mass or unbalanced force. So for this I have taken scale as 5:1. Okay. Then need to construct the couple polygon. So for couple polygon only one unknown is there, that is 0.06 bm. So we'll start from this first one. So it is with a negative sign. So start from here. O to A, it should be in magnitude it should be 0.375. Here I have taken scale as 10:1. And A to B angle is 90 degree and the magnitude is 30. Then B to C 1.35 in magnitude and angle is 210 degree. After that join this C to O to get or to complete the couple polygon. So this C to O should be equal to your unknown quantity, that is 0.06 bm, and should get the respective angle as theta m as 13.5 degree. Once we get the mass in plane m and their angle, then go for the force polygon. So first O to A 1.25 in magnitude, then A to B 90 degrees is the angle, 1 is the magnitude, then B to C 1.5 is the magnitude and 210 degrees is the angle, that is up to here. Then at last you can take this 1.1 bm, and that value you already got it from the force polygon. So C to B 2.65 in magnitude and angle is 13.5. Then join this D to O to complete the polygon, and length of this D to O should be equal to 0.1 bl, and this angle is going to be your theta L. So for this I have taken scale as 5:1. So now looking for the calculation part. So unbalanced force, that is from the first force polygon, that is from this force polygon, OC should be equal to unbalanced force, OC into scale into omega square. So for omega square we have the formula 2 pi n by 60 whole square. So if you substitute that one, you will get 246.74 Newton as the unbalanced force. Similarly, for unbalanced couple, it is OC into scale into omega square. So it is 15.9 into 1 by 10 is the scale which I have taken, that is from this couple polygon. OC I have to take, then 2 pi n by 60 whole square. From that you will get the value as 1569.79 Newton meter. And now coming to the determination of unknown masses. For the balancing masses on planes L and M, from couple polygon 0.06 bm should be equal to OC into scale, that is from this polygon OC should be equal to 0.06 bm. From that you will get the value of bm as 26.5 kg and theta m as 13.5 degree counterclockwise direction. Similarly, from force polygon 0.1 bl should be equal to OD into scale. BL is 27 kg and theta L is 200 degree in counterclockwise direction. So here, while solving the problem, first you need to construct this line diagram and space diagram, then this tabular column. For that you have to decide which polygon you have to draw first, whether you have to go with force polygon or couple polygon. We start with the polygon or from the column in which we are having least unknown quantities. And the varieties of problems are like, sometimes he will not give any information about the angular position. At that time you have to ignore the balancing planes, you have to consider only the known quantities for this, and you have to assume that the system is in static balance. For that you need to construct the force polygon, that is static force polygon, from which you will get the angles for the least two masses. Then you have to use those angles for the construction of couple polygon and force polygon. And here, while taking the reference plane, always try to take a reference plane on which plane the mass is unknown. So with this we'll conclude the module, that is balancing of rotating mass. If you have any query, you can leave the comment in comment box. Thank you.